Let's do another example of the left and right hand limits of this piecewise defined function g. So we're going to find the left-hand limit as x goes to 2, the right-hand limit as x goes to 2 of this piecewise defined function. Now, I know you could do this on your own. We've done ones very similar, but I'm going to go through this immediately. So start with the left-hand limit. Limit of g of x as x goes to -2, since we're plugging in numbers that are underneath 2, that means we're going to be plugging into the 3x minus 1 expression, and that gives me 3 times 2 minus 1, which is 5. So I end up with a 5 as the left-hand limit. The right-hand limit, well, the right hand, I'm going x is above 2, so I'm plugging in the expression, or plugging in numbers into the expression x squared plus 1. And so I can do that with my value of 2 because we know how to work this algebraically or analytically. And it turns out we also get a 5. So even though this function was piecewise defined for values under 2 and values over 2, we actually got the same left-hand and right-hand limit. And when that happens, what we can do, since both limits were the same, we can say, well, therefore, since the left-hand limit and the right-hand limit led us to the same value, the limit of our function as x goes to 2 is also that same value. In other words, we can say the limit in either direction is 5. And that's going to happen. So the limit is going to exist whenever the left hand and the right hand limit both exist and are equal to each other. So graphically, what it looks like is our two pieces here. I've graphed them in different colors so you can kind of see where the change is at. But as you approach 2 from the left, you're on this red part, and it approaches the point 2, 5. And then as you approach 2 from the right, it's on this blue part, so you're also approaching the point 2, 5. In other words, the two parts basically match up at that point 2, 5. Now, we can do this for any limit and any function that we want. And so the connection to a limit and those one-sided limits is that if I have a limit that exists where x approaches c and in either direction I get L, then the left-hand limit and the right-hand limit are both going to be L. Also, if the left-hand limit and the right-hand limit are both L, that's what we're saying here, then the limit itself is going to be L. Okay? So saying that the limit exists and is equal to L is the same thing as saying both the left-hand limit and the right-hand limit exists and equals L. So here's what I'd like you to do. I'd like you to see if that same thing holds true for this h of x function. Go ahead and stop the video and find the left-hand limit, the right-hand limit, and the limit as x approaches -2.